Okay, so today we'll be looking at how to make a simple plasma generator. Um, it sounds a lot more complicated than it is. It's really just buying a component. That's it. But okay, so what it comes down to is we're going to use an arc generator, a high voltage arc generator, specifically a 40 kilovolt arc generator. So yeah, it's quite you don't want to be shocked by this thing. But so we'll use an arc generator and we'll essentially generate plasma with it. So just looking at the definition of plasma, I'll just read this off. Plasma is a superheated matter so hot that the electrons are ripped away from the atoms, forming an ionized gas. It comprises over 99% of the visible universe. In the night sky, plasma glows in the form of stars, nebulas, and even auroras that sometimes ripple above the north and south poles. That branch of lightning that cracks the sky is plasma. So are the neon signs along the city streets. And so is our sun, the star that makes life on Earth possible. Plasma is often called the fourth state of matter, along with solid, liquid and gas. Just as a liquid will boil, changing into gas when energy is added, heating a gas will form a plasma, a soup of positively charged particles, ions, and negatively charged particles, electrons. So essentially that is the basic definition of plasma. So it is, well, it sounds very complicated, but it's very easy to actually generate, and it all comes down to some very specific manners, so or specific conditions to be able to generate plasma. So let's first look at what those conditions are. Okay, so when asking ChatGPT whether 40 kilovolts is enough to generate a stream of plasma, well, this is the answer it gave. So how correct this is, that's probably up to somebody who's more experienced in this to determine. But first of all, okay, so it says 40 kilovolts is a high voltage and can ionize the gases under the right conditions. When the voltage is high enough, it can strip electrons from gas molecules, creating positively charged ions and free electrons, which are the constituents of plasma. And then the next important factor is the environment. So it says a proper gas environment. Plasma is often formed in gases. The type of gas used and its pressure are critical factors. Different gases have different ionization potentials, so some gases are easier to ionize than others. The pressure of a gas also plays a role. Higher pressures may require lower voltages for ionization. And the next thing is the electrode configuration. The distance between the electrodes and their geometry can influence plasma formation. If the electrodes are too far apart, the electric field strength may not be sufficient to ionize the gas. Conversely, if they are too close together, an arc discharge may form without the creation of a stable plasma. Okay, so the next up is the purity of a gas. The presence of impurities in the gas can hinder plasma formation and affect its properties. Okay, the temperature of a system can influence gas formation. Higher temperatures can make it easier to create and sustain plasma. Other factors, the rate of voltage rise, the current flowing between the electrodes, and the overall circuit configuration also plays a role in plasma formation. So what's important to note here is that plasma, since it's considered the fourth state of nature, in the sense of it is both affected by pressure and by temperature. So now if we increase the temperature and increase the pressure, it means we essentially need a much lower voltage to generate plasma. So therefore, okay, which is actually quite, now that I think about it, quite strange that in space you've got a vacuum which has no pressure. So essentially you would need extremely high voltage to generate plasma. So which just interesting. How do the NASA guys do it? I'm sure there's videos and information on that, but just something worth thinking about, because if it's easier to create plasma with a higher both higher pressure and a higher temperature, then you have to think in space. The pressure is like non-existent, it's a vacuum, and the temperature is like freezing. I'm not sure what temperature. I assume freezing. Maybe it's warm enough where the sun is shining. But either way, so just something worth thinking about. That how do they actually accomplish generating plasma in space itself? So a lot of processes actually do use the concept of generating plasma in a vacuum. So I guess there's some factor that I'm overlooking or that's not being stated over here. So, but yeah, interesting to note. Is the sound that you're hearing, that humming sound, is affected by the distance between the two probes. Now obviously if I bring the probes too close together, there's an arc and it ignites, or ignition arc that forms. Okay, and that shows you it's never a good idea to use your foot as an extra pair of hands. A big no-no that you'll see in this video, and that's causing some problems, is that the circuit is actually short-circuiting at the point where the power is being supplied to this. If you look closely, you'll see the crocodile tips are just touching each other, and they're way too close. Okay, so at this point we're actually generating plasma. As you can see, there's a small, tiny little stream of plasma being generated when the probes are at just the correct distance from each other. Now what's also really interesting to note is the interference with the camera that's occurring during this arc ignition. So hopefully this showed you some of the basics of generating a plasma stream. It's not very difficult, you just need to be very careful with what you do. And it gave me some ideas of some things to do in the near future. Stay tuned, I already have some new videos lined up if you're interested in seeing some additional plasma related experiments. But anyways, thank you for joining me. I hope you enjoyed the video, I hope you found it informative, and I hope I didn't waste your time. Enjoy your day.